Greetings, Pythonistas. Welcome back to School of Tomorrow. We're continuing with our mastery of Python topics. Like we studied Pascal's triangle. A few videos ago, I showed you in the Spider IDE how to write a generator to generate what we call the rows of Pascal's triangle. Now this animated GIF here, this is a little bit different. It's just showing alternative pathways. If you're like a ball falling from the top to the bottom, the idea is at each blue peg you have a choice to fall either to your left or to your right. Now if you're already on the edge, there may be no further, well, you can always fall to your left or to your right. Let's put it that way. So if you always fall left, 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 very unusual in a random roll of the dice to always roll an L or flip a coin. You always get heads all the way out to the edge. It'll happen though, very occasionally. More often, your left, right, heads, tails is going to get you somewhere towards the middle because there's going to tend to be as many heads as tails. So what we do in Codesters is write a simple program. Here's kind of how it looks when it's running. I'm going to start it running and talk about the code while it is running. See if that works. So what happens is we create a succession of turtles that fall from the top. You could say there's no gravity turned on. We're just moving forward. And we're also computing a path. And we're computing the path ahead of time. And we're saying it's going to be 25 long. And it's just going to be a sequence of left-right choices. And this turtle also falls straight down after it makes a choice. It goes left or right, and then it goes straight down, and that just makes this pretty hexagon pattern, but it's still going to be the same principle that more turtles aggregate towards the middle than towards the edges. So as I scroll through this, I see the turtles might be slowing down a little bit because the JavaScript has to keep up here. Remember, Codesters is emulating Python. It's running in your browser. Your client-side browser is able to do all this using JavaScript. It's not like there's a server somewhere far, far away that has to do a lot of processing here, okay? So I asked for 100 turtles. Let's just quick look at the code. You can make your own Galton board. I just want to give you one way of doing it. First of all, computing the pathway is pretty straightforward. You just start with an empty list, which I call path, and then I use random.choice to just get left, right, append that in a loop of however many times I want to do it, maybe 25 times. Now make turtle is kind of the core of it. We create a new turtle at the top, get the colors and settings pointing down from the top of the screen, and then run the move it program on that turtle. Now what move it does is it grabs pathway immediately as an argument. So it calls the function pathway and gets the left, right, return list as the result of that expression. In other words, calling pathway magically transforms this expression into a list. Left, right, left. So we feed that to move it as a list. The path is a list. In modern Python, I could put that this was a list like here. It wouldn't necessarily enforce it, but there I could document it. I could annotate it. And we're going to move this sprite left or right is going to dictate whether we face at 210 degrees or negative 30 degrees. So those are the angles we want to face depending on left or right. We go forward 10 and then we face straight down again. And when we go around the loop, because it's in a for loop, there's our free fall for 10. So we do fall and then make another choice and then fall again and so forth as many times as we need to run our path. So you can see over on the right here, I don't have any total outliers. I might have to run this thing for a very long time before I got any turtles as far out to the right as could possibly be. This is where we talk about probability and statistics, the fact that this is a pseudo-random number generator, whether it starts at the same place every time, whether we can reseed it, is it Can we make it more biased? Can we make more outliers appear by changing the choices that it has to make? What can we do? Can we change colors? All of the above are interesting experiments. Just suggesting that once you get code like this going, you might as well start playing with the parameters and changing things. So way at the bottom is where I drive it all by doing a 300 turtle loop, and make turtle takes care of the rest. And then I do have a slight pause of 1/10 of a second every time a turtle's finished, but that's hardly perceptible, right? So if you go out on YouTube, you'll find Galton Board is a meme, and there's a ton of things you might want to watch regarding how that relates to the probability curve we call a bell curve, right? There's all kinds of very good teachers out there who have really good explanations, and I invite you to come back to my channel when you're ready for some more of the kind of stuff we do here, right? It's not either or. We're a big community. I'm going to leave this running. Maybe in a future video I'll show you if it ever manages to get really far out to the left or right. So far it's pretty middle of the road. All right, talk to you soon.